Welcome back to my channel. So today I'll be going through PSLE 2024 question number 35. Okay, let's begin. Okay, so Hoxing moved part L to compress a spring for launching a ball as shown in the setup. There is no wind. Okay, move part L. So he probably moved part L downwards to compress the spring. Okay, so he measured the distance moved by the ball as shown. His result is being shown over here. Okay, so you have the path of ball being taken over here and then it land into the water. Okay, so so certain words like spring the ball the path of ball, the splash, the water, these are more or less quite important words that maybe later you might use it. Okay, so he measured the distance moved by the ball as shown, then this is the result. So state how the distance moved by the ball change with the angle or change with the launching angle. So in this case, very clear cut, the launching angle is actually a change variable. Okay, so usually things that is on the left hand side of the table is actually your measure variable. The distance moved is something that is being measured. Okay, is your measure variable. So how do you really know? Sometimes you see the verb measured. Okay, measured suggests it must be the measured variable. So the phrase come after that will be your measure variable. Distance moved by the ball. Okay, so in this case, and notice how question A is being phrased. State how the measured variable change with change variable. So in this case, you must write the change variable first, followed by the distance move first. You need to swap them around. So what I mean is you have to write the launching angle first, followed by the distance move. And you notice this is a 2 mark. So in this case, you have to look into the data first. So let's take a look. When 15 to 30, 15 to 30, 48, 87, 50, 84. So this is the distance move. And you continue to move. If you continue to read through, right, until 45, right, you realize that 15 until 45, right, these three, this distance moved by the first and second try, they are always increasing, right? So when you increase the launching angle, the distance move increases. But you notice one thing, okay, from 45 onwards to 60, it actually decreases. So the relationship is as such that it's an increasing component and a decreasing component. So if I were to draw it on a graph that looks like this, right? So it will look something like this. This will be the angle. This will be the distance. There's a highest point here, so it looks something like this. Okay, this is 45 degree. So this is up, this is down. So probably I can say 15, 30, then after that 60. So in this case, you can see very clear cut. So let me just highlight it to you. From 15 until 45 increases, the distance move increases. Okay, from 45 until 60, this launching angle continue to increase, but the distance move decrease. So there's two sets of relationship that is over here. Okay, so maybe I put it on the graph, it is much more easier for you. So this is how it will look on the graph if I change from table to the graph. So this part of the relationship can be written in this way. Okay, as the launching angle increases from 15 to 45 degree, okay, the distance moved by the ball increases. Okay, then you go on to talk about the second mark of the relationship. Okay, as the launching angle increases from 45 to 60, the distance moved by the ball decreases. Okay, on this portion, this decreases, increase, and this one is increase. So these are the 2 marks. Okay, especially when you see this kind of word state how variable 1 affect variable 2, right? This is usually a relationship question, but you have to write the relationship very carefully. Okay, and really read through the table, scan through the numbers, see whether you can identify an increasing followed by a decreasing trend or not, or whether is it an increasing or remain the same trend. Okay, so sometimes the graph can be something like this. Okay, can be something like this. It increased and somehow it remained the same. Okay, so you have to look at the data very carefully. Okay, so name a force acting on the ball at X. Okay, force not energy force. So actually in this way that the ball is in the mid-air, there will always be a pulling force exerted on it, and that will be your gravity. Gravitational force. Okay, or sometimes some of you may write gravity. I think it's also fine. Gravity. Okay, maybe let's write it. Okay, gravity. Okay, this is also fine. Okay, why is it difficult to measure the distance moved? Okay, so you take a look. The ball is landing on a water body. So water body, they make some splash, right? So imagine you are the person trying to measure it, right? You when the ball hit it, right, it straight away more or less it sinks to the bottom, and then it creates that splash. That splash is only exists in a temporary moment. You cannot really mark it out across or mark a location over there to say where the ball landed. So it's very difficult. So in this way, this actually, because of the way the experiment is conducted, it is conducted on a water body, right? It affect your accuracy. So in this case, if this setup were to conduct on a sand, okay, it will be much better. It will increase the accuracy. So in this way, right, this is actually something to do with accuracy. So let me show you on this part. So when the ball hit the water, it causes splash and sink. Okay, it makes it hard to see the exact point where the ball landed, which will affect the accuracy of the distance measured. So this is the key portion. Affect accuracy of the distance measured. You don't know where exactly it landed. Okay, so this will be part of the answers for part C. Okay, so sometimes they may ask you suggest one way to improve this setup so that the distance move can be measured more accurately. Change the water to wet sand. Change the water to wet sand, so when the ball land, it will make a marking. It's easier for the person to measure the distance. So this could be one way. Okay, so Hoxing repeat the experiment using the same set of angle, launching angle when there is no wind. He used the same setup but a similar ball of a higher mass. So he want to try to test whether a ball of a higher mass will yield the same result or a very different result, or if it's different, how different it is. State a variable that must be kept constant for a fair comparison of distance moved. Okay, in this case, he already says same setup. So if you take a look at the diagram, you cannot tell me about change to a stiffer spring, change to a lefty spring, or change the water to the sand. Nothing to do with this. Okay, you have to state something like in this case, one way to ensure that it's a fair comparison of the same distance move, right? Because you have to make sure that the compression over here, the compression must be the same. The compression must be the same. Okay, because if the compression is more than the previous experiment, then the ball will go further. Okay, so you have to make sure that the compression is the same. That is a variable that you have to keep constant. Okay, so this one, the amount of compression of the spring must be kept the same. Okay, so certain answers will not be accepted because I already tell you same setup. So you cannot tell me stiffness of spring, the launching angle, type of surface. Okay, type of surface where the ball land, for water versus sand. You cannot say this kind of thing. Okay, the height of the launch position. Okay, which is this part. Maybe you put another platform over here. You raise it up higher. Then there is more than one variable change. Then this is not a fair test. So these are the common common answers that students usually give when they do not read this part. Same setup. Okay, this word same setup, that means it's very restrictive already. You can only think about what is being done in the setup, right? That will affect how the distance move. But we are not talking about the apparatus itself. We are talking about certain things that you are doing. For example, the compression. So this part you have to think a bit harder. Okay, so with that, so this is more or less I'm done with this question number 35. Okay, thank you very much.